Yeah, hello everybody. So I am Andy. Actually, my first of a little detour on what we do now. We switch a bit and go a bit away from the metal onto avatars. Cause my background is actually game development. So I'm a computer scientist. I deal with bytes, not with bolts, basically. So I am about code, I am about implementing stuff. I'm also like a developer, so I build software structures at the end of the day. And so I'm not a roboticist. I have no idea how the metal moves. I just try to decide, like, should it move? So that's basically the thing that I want to do. And in that, I want to talk a bit about emotion and agents and what emotions actually are, what agents actually are, and how these belong together. And then we will draw some parallels to one industry that already uses that quite a bit, also in a way different form, and that's the game development industry. That's also where I originate from, before I detoured into branding. Okay, so first off, what are emotions? So, at the very, very first, a little detour, or a little disclaimer. What we do now is like the engineer's view on all of this. It's not necessarily the scientist's view. So I want to basically hop over. So far we looked at robots and emotions, basically on how they change the way humans see the machine or humans interact with the machine. Now I want to take a look at, okay, we as an engineer, we want to build a machine that is capable of expressing emotions, of simulating emotions. What do we need to do? So basically the emotions cookbook. How do we implement emotions? So we are now on the side of the machine and we want to see how we do that. So we will stack up and gather some best practices on what happens there. So the interesting thing is about emotions at first hand is that apparently we as humans, we invest quite a bit of energy into it. Emotions are a very cognitive complex task. Basically, most of the brain is concerned with dealing with emotions, so it's not like you can locate fear in a single spot. Yeah, we can because it's like this basic, but the actual expression fear that you feel is something very complex. That's why you also have so many different kinds of fears, for instance. And why am I using fear? Because fear is pretty well researched. You could also use love in something, but then it gets even more complex. But you can also express, feel love for all kinds of things. And similar it is for most emotions. So let's find out how these relate to software and how we can actually implement something like that. And if you target something here, then you typically target something that's called an agent. What is an agent? An agent is basically the piece of code, you could say the brain of a machine, or the piece of code that actually decides which decisions have to be made. To basically decides and tells you, okay, these are the actions to do. Not necessarily how they are being executed, but should they be executed. Typically also that doesn't always happen, the system that plans ahead, that tries to steer action, that tries to perhaps steer a conversation, that has a plan, that's the agent. Typically a rational agent, where rational agents mean that you do rational decisions. Rational means that you always do the decision that maximizes your own values, whatever the values are. So your own fitness, your own goals that you want to achieve, which are typically explicitly defined, but that's another topic. Everything on board so far? Awesome. Okay, so here, if you approach it from this angle, from implementing emotions on the scope of a rational agent, what you then see there is that in game development, for instance, you typically split this into 3 categories, where emotions themselves are basically this is not the same vocabulary that we use to describe human situations, right? It's just what you would do in software development, what you do in character development in games, for instance. Where emotions are the situative modifications to the rational decisions. Because it's really interesting. If you have a purely rational agent, then this is typically a very inhumane way of doing decisions. We humans do not do rational decisions. We have biases on them, and these are typically called the emotions. That's very different to the typical example is you say you build a supercomputer, the UN builds a supercomputer. right? And then the UN gives the supercomputer a task, like, please cure Ebola in Africa. And then the supercomputer says, yeah, no problem, I can do that. I need the codes for the nuclear missiles. Because nuking everybody in Africa is a good way to cure Ebola. But you will say, like, wait, this is not like what we intended. Right? The missing context, obviously, it was not aligned, right? The whole discussion that we have right now. But that's a rational decision. But it's not like there are a lot of emotions and a lot of information missing. So that's what you typically call like emotion. So it's basically, it has something to do with the whole alignment discussion that we have in machine learning currently. That's actually about that. Don't do rational decisions always. Do decisions that actually match the emotional setup that you have. So these are modifications on rational decisions. First thing, and you can implement this very, very easily. These are just like some examples that you have. You can ignore certain pieces of knowledge. You can add certain pieces of knowledge, stuff like that. You can change reward functions. Just some examples on what that means in practice for people who are developing and who are using some of these systems. Then on top of that come basically the traits. What are traits? Traits are basically the long-term effect of emotions. So that's basically how often do you end up in a certain set of these emotions. So how often, for example, do you devalue a certain rational action. So say you have a set of actions and you say, okay, these 4 actions, for example, like gathering information, like if you devalue gathering informations often, then that's a trait of your character. Does that make sense so far? So that's basically the effect over time. And then at the end of the day, the thing that you actually perceive, that you show over the long run, that's typically the thing that persists throughout user sessions, so that you actually can perceive over multiple sessions. That's called then the behavior. That's something that typically sounds more like a character trait that we would associate to humans. Like if you have a system that typically like tries to engage into more conversations, then that's something that's like a reassuring agent. Does that make sense? So that's just like the basic setup. If we can agree on this vocabulary, then we can like dive a bit into the actual code behind it, because that's the basic setup on how characters are developed in, basically in games or in other interactive simulations. Okay, so hop into the actual game development part. If you actually take this metric, like these 3 categories, and you assess that for the average game, you will find out that, okay, there are not so many different ways on how they are done. Typically, emotions are implemented with utility functions or something very similar, sometimes a behavior tree, but typically utility functions. When you go into traits, it's more often than not actually just templates, which is a glorified way of like telling you it's if then else. And behavior is typically hard-coded or missing at all, which is quite interesting. So that's like for the typical game. So for the typical game, and why is that? A typical game does not need a long-time behavior of agents. Why does a typical game not need long-time behavior of agents? Because agents in a game fulfill a very specific task. They are a bit like actors in a movie, right? They are typically not that autonomous. They're actually pretty primitive at the end of the day. And that's basically the context of all of that. A character in a game has script and has a lot of artists making it in a way that like the agent expresses it, that the micro interactions, that the animation stuff that we saw earlier already matches really well. So that works well. An autonomous agent like myself, just running around here, does not have this nice benefit. I don't have a director telling me what to do. I don't have I have to actually take care of my animations myself. That's a really, really huge difference. And the interesting thing is, couldn't we close this gap? So that's basically the industry standard, the stuff that we have nowadays. And that ends up more or less working that way. That ends up more or less having the behavior, the script, be like a director, a piece of code that just tells the agent, okay, do this and that. How should you interact, which dialogues should you run. Traits are just like basic templates, and these are utility functions. So that's probably the most complex one, and utility functions are basically just stacking up some numbers and then taking the best one. So this is also very, very simple code. Can we move from that very simple template to something more in that direction? And I'm not the first person asking that. yes, you can close this gap, and there are actually games doing that. How do they do this? We take a look at the basic setup of a reasoning agent. The very basic setup of a reasoning agent, that's now the same for robotics as well. Is okay, we have some world out there, some objective reality. We perceive it through sensors. From the sensors, we make ourselves a model. That's our view of the world, omitting a lot of details because memory. And complexity in general. On top of out of the model, we can formulate an action space. So that's the possible things we could do right now, right? Can be like discrete, can be pretty complex. Then we have some reasoning system. That's where all the planning happens. So there are a lot of that's its own talk here. So there can happen a lot of planning. At the end of the day, reasoning is the problem of selecting one action out of the action space. Then we apply the action is being executed, changes something in the world, and then the whole thing starts over again. Okay, so that's the basic setup of a reasoning system. Now the interesting part is, okay, what is different here from any idea? What is different between this general setup in reality and in a game? One of these boxes is really, really different in the game. Any idea? Any advantage that a game character has on top of a robot? I know it's not an interactive workshop yet, but we will try. A very, very huge difference is how you perceive the world. The big problem of robotics in general is that you are always dealing with noisy sensors. You have a camera receiving some pixel images from which you have to find out, oh, that's actually a tea bottle standing over there or something like that. A game character has basically the phone number of the universe. We can actually ask what is in front of us, and you will get a clear, correct, and accurate answer back. Like there's a bottle there, you can consume it, it restores 20 stamina, something like that. That's a huge difference. Because the whole sensor layer is a big mess if you deal with reality. If you are in a simulation, that's pretty neat. So you can focus more on these parts. Okay, how do you gap over from the pretty hard-coded and static agent over to something that is more interactive? And that's basically the core idea that I had earlier. Why not have a director? And there are actually games that do that. Alien Isolation was a pretty popular one a while back that started that. So the core idea is split the actual reasoning system that you perceive, the controlling system of a machine, split it up into multiple agents, right? So essentially have one agent that is as simple and stupid as it was as all the other game agents are, and have one agent that actually tries to be the director. So have one system that tries to create scenarios that actually populate lists of potential attributes that takes care of the long-term behavior, and have that one create the story scripts for the underlying agents. And I think that's a pattern that we can apply to robotics as well. We see this quite effective in a lot of applications in games. That's actually the pattern that most game AIs nowadays are. If you take a modern game, most of the systems start working that way, that you have these hierarchies. Actually, it's a bit more complex in reality, because even these agents are typically split up into 2 or 3. So we are typically talking what you perceive as one character in the game is typically a set of a bunch of agents. So it's a multi-agent hierarchy, a bit like a multi-agent system, just that not each agent is an individual entity in the world, but each agent actually controls just this single entity. So you have 10 agents controlling a single entity with a lot of hierarchy and basically some kind of, you could call it parliament, so some kind of mediating system that actually describes or tries to formulate which of them then takes the actual control of the entity, because only one can actually issue an action. So these are the ways these systems work. And what I would really like to see, or what I would really like to push, is adapting these systems for social robotics. We are already doing this a little with Honda. The Honda Haru project is something here run by the Honda Research Institute, where you're also part in. And we are trying some of these approaches out. We have a little prototype. We are also building a simulation there for Haru, for the robot, which is basically built on WebGL. So it's actually a game character, so to speak, where you can try these things out. And that works quite well so far, but it's just prototype, so I don't have data yet. But I can already see that working. So I would really think that this is something for social robotics. It's really interesting. The games industry in general has a lot of potential there, because there are already a lot of agents out there that actually work. And yeah, that's basically my little proposal. Later on, we will take a little look at brand development, where we can also like take a little detour and take some inspiration from. And yeah, that was a little detour into game development. And I'm open for questions.